This faulty Nintendo Switch Lite that I bought off eBay has a very interesting story. I only paid a total of £38 for it, but this is the listing. Unit was bought with a faulty USB-C port, sent it to a repair shop who spent 4 months doing nothing with it until pressed. They appear to have hastily replaced the USB-C port, but it doesn't turn on, missing some screws and has marks to its shell. And today I'm going to take it apart and see if I can fix the mistake that the repair shop made. Here I have a USB ammeter which tells me a rough idea of what's wrong with the Nintendo Switch. You plug this into the USB-C charging port and sometimes it tells us exactly what we need to know. On this occasion, however, I'm not going to do that. Because they've replaced the charging port, I have no idea what's wrong with it. Let's have a quick look under the scope. It doesn't look like there is actually anything wrong with it at all. At this point, I can't tell if they used a Dremel, which is what you normally have to do if you purchase a normal Nintendo Switch port, or whether they have replaced this with an actual Nintendo Switch Lite port. You can see that down the bottom, we have the screws missing next to the charging port, and the story is the same all the way around the console. We have screws missing left, right, and center. In fact, there's not one screw in place. The reason why I'm going to avoid charging this straight away is because if the repair shop has soldered the port incorrectly and I put a charge through the console, we could end up making things worse. That's not to say that the previous owner has already done this, but I'd rather not do it just to be safe. Just before we take apart the console, as you can see, it's not in the best of condition. We've got some sticker on the back here as well, in which case, if there are no screws, I should be able to just quite literally pull the shell apart. Oh my God, I don't think the motherboard's even screwed down. It's not. We have our first bit of debris that's fallen out. I'm going to highlight a couple of things that are wrong with this. There's no heat shield. We have no screws at the charging port, the heatsink fan. On the actual motherboard itself, we're missing one here and here to secure the speaker, which is just completely loose also. And there's no screws at all in the game cartridge slot or the headphone jack. I think it's fair to say that this is an absolute shambles. The board has been removed and I'm just going to clean up the thermal pasta that we have around the CPU area just to get it nice and clean. It would be amazing if we can give this Nintendo Switch a new lease of life. But if I'm honest, I'm quite doubtful with this one. Much better and a cleaner area for us to work on. Let's go back under the scope and inspect this charging port. First thing I want to note, which is actually pretty good, is that we have all of the tiny resistors around here. It's very easy to lose these, especially when you're applying heat to this port. The battery connector is also a bit singed. So what that tells me is that the technician who worked on this applied heat directly from above, but got a bit too close with this connector. Let's test the pins on this to make sure that it's definitely solid. It's not. Look, you can see straight off the bat that this pin is wiggling. This one isn't solid, this one is wiggling, this one is wiggling, this one is wiggling also. So this port is not on correctly at all. If we flip the port over and have a look at the back, again you can see that the solder hasn't come all the way through the ground pads here, which means that it also wasn't secure enough. And to be honest with you, this looks like a Nintendo Switch port because of how far it comes away from the board. When I use a Dremel, I make these ports a lot shorter to fit in the case. And I usually try and Dremel in line with the circuit board itself. So I'd probably say it's about 1 millimeter too big. First things first. We're going to remove this port by applying heat from the bottom. Then we're going to use our multimeter to test our BQ charging chip and M92T36, just to make sure that this port hasn't caused any more damage. So let's do that now. As long as they've used leaded solder, this isn't going to take long at all to get the port off. First things first, we're going to flood this sucker with a bunch of flux. There we go, over there and just over here as well. And we're going to put our heat gun to a temperature of 450 degrees Celsius with an airflow speed of 70%. Now I can turn around and say that this is really clean. Oh, wait a minute, we have a hole here. Is that flux or is that? Yeah, it's just flux. Okay, good, it's not solder. Now let's test the M92T36 chip on the back and see if we have any shorted components. So the meter goes into continuity mode, which is the mode that beeps when we have a complete circuit. One probe goes on ground and the other, the red one, I use to see if we have any shorts. Starting with these caps down here. Okay, we have a shorted capacitor here. Let's just continue checking. These ones are fine. This one's fine. This one's fine. Oh no. Okay, so the CPU cap that we have here, which I believe is linked to the CPU, is also shorted. I've had it before with a previous Nintendo Switch Lite where this cap and this cap are shorted, and I've removed this cap, this cap, this cap, and the M92T36 chip, and the pads underneath these caps are still shorted to ground. Some people said that I gave up a little bit too easily on it, even though I removed a few components. So I'm not going to do that in today's video. We're going to carry on and we're going to see if we can remove the short to ground that we have on these two caps. Let's continue looking at the BQ chip. Caps around BQ are fine, so I'm going to go ahead and assume that BQ is okay. And remember, the port has been removed, so these shorts aren't linked to the port, but I definitely think the old port caused some issues. Maybe this is why the repair shop weren't able to fix it, is because they missed out on the fact that there was two shorted capacitors here, and even though they'd done a port swap, it wasn't going to work. But the port swap itself that they done wasn't a fantastic job, so it could have been either that caused it, or maybe this was the original fault. Here I have a Max IC BGA chip. This is Max 77812, and some people in the previous video said that this chip could be linked to the shorts on the other side of the board. If I have my meter in continuity mode again, and I test some of the caps, that's shorted to ground on both sides. This one isn't. This one is. The rest of them are fine. So we have this cap up here and this cap down here that are shorted to ground. And this one as well. I'd be inclined to guess that it's because of this Max chip, because I have nothing else to go by. I have a couple of options here, and the options are install a new port, plug the charging cable in, and then we can see what component is getting hot on the board using a thermal camera. However, if it's not drawing enough amps, we're not going to be able to see what component is getting hot. And there is also a risk that I damage more components using that method. So I think our best bet is to just try and remove the Max IC and see if this short goes. I'm also just going to place a bit of flux on here and run my iron over with some solder to make sure there's no bridges underneath. And now just some isopropyl alcohol and a cotton bud. There we go, and as you can see, there's no pads touching there. Has this got rid of our short? Back in continuity mode. No, you see, look, we still have a short on these caps. This one as well. This one, everywhere still has a short. If I turn to the back of the board and we go back to the M92 chip, let's check this cap and this cap to see if we still have a short. Yep, 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 yep. So we still have a short on both of these caps, even after removing that Max IC. I'm just having a look on the board now to see if there's any other components we could remove. I am thinking about just removing these caps that are shorted here to see if the short is any one of those. I doubt it because they're on 3 separate tracks. All of these coils have continuity as well, so they're not an issue about this one. Yeah. The caps I'm going to remove is this one, this one, this one, and potentially this little guy here. How are we looking now? Do we still have a short to ground on the pads? Yep, we still have a short on that cap, on that one, and this one as well. So we still have a short in all the areas where we just removed those components. I'm just testing random caps as well on the back of the board to make sure and see if any of these are shorted. And what I've come across is that a few of them are. So this cap is shorted, but it's a short to ground. But this one's fine. This one's okay. This one's shorted. And then if we go to this area here, this is shorted to ground, this cap here. That cap is shorted. So everything on this line is shorted as well. And whereas this on the other side of the board, it's under the RAM. So here we have the shield that protects the RAM here and the CPU here. Just testing for shorts again anywhere else on the board. Now it could be that these caps here, which are again underneath the RAM to be precise, are low impedance, but it is a dead short to ground, so I'm not getting any ohms whatsoever. And I believe low impedance on my multimeter is under 50 ohms and it beeps. Let's check around this Max IC as well. Okay, so there's shorts around here as well. You see how it goes into this Max IC, this side. That's shorted to ground, that's going into the Max IC chip. This one is shorted, this goes directly into the chip itself. Let's remove this Max IC and see if that does anything else. This one is still shorted, this one's still shorted, even though we've removed it, and this one is also still shorted, so that didn't make a difference either. Worst case scenario, by the way, I just use these max ICs in other Nintendo Switches, so it's not a huge loss. This is underneath the CPU itself here. And we're getting shorts here as well. See that? This cap here is showing 12 ohms, so that might actually just be a low impedance cap. I don't know if that's a cap or an inductor. I think it's a cap. This is showing 4 ohms. Again, might be low impedance. 4 ohms. So it's hard to call if the CPU is dead around here because a lot of these are low impedance. I'm going to take off the shield and I'm going to try and reflow the CPU and the RAM as well. And then if that doesn't work, I'm going to put a port back on and give it some voltage and see if anything gets hot. Clean off the thermal pasta that we have around the CPU. Lovely jubbly. Just a quick reminder as well, when I started watching people on YouTube do this sort of stuff, diagnosing and fixing games, consoles, electronics in general, I thought I'd never be able to do it. But I think I've already proved myself wrong by getting this far already. So if you're watching this video and you think, I can't do this, you can. If it's something you enjoy, if you put enough time, energy, and love into it, you will reap the satisfaction of fixing a device. Okay, here we have the behemoth tip, which as you can see is big enough to cover the RAM and the CPU one at a time, obviously. 460 degrees Celsius with an airflow speed of 99%. I've tried to clean up the flux as best I can as well, but I also had to use a lot of flux. I think that was a success. We managed to get a bit of movement by poking the CPU when it had a lot of heat applied to it, as well as the RAM chips as well, but they snapped straight back into place. So let's see if that rectified the short. I'm gonna go straight over to M92T36 and we're gonna try this cap here. Moment of truth, come on. Here we go. Still a short. Still a short here as well. So the reflow, done nothing. Checking these caps that were underneath the RAM, still bad. I think next we put a port on and we see if there's any heat coming from anything in particular, but I'm pretty sure it is going to be either RAM or CPU. Also, I think what I could do is just put 20 volts into the fuse here, but it's good practice for me to do the charging port way. Right, new port has been soldered on, but unfortunately we still get a 0 amp draw, which completely makes sense. I've just put the heat camera over the RAM and the CPU and I can't find anything remotely hot, but that's because we're not drawing any current. Might also have something to do with the fact that we've removed a bunch of components. I've just put it in the housing very quickly and we're getting a 0.47 amp draw, but I'm pretty sure it's just going straight to the battery, because if I use my thermal cam, this is exactly where the power's coming in and this is where it's charging the battery, you see. And if we look over the CPU and RAM, which is here, it's fine, unfortunately. And now for my final test, I'm going to remove the RAM first to see if that gets rid of the shorts, and if it doesn't, I'll remove the CPU and then at least we can confirm. You could argue the fact that it could be a component that's going into the CPU which is then causing the short, but I have nothing else to go by currently. Okay, now the RAM's off, let's check and see if the short's gone. Okay, meter in continuity mode again. Do we have any shorts around here? Yes, we do. This is the back of the RAM, by the way. Still a short. Still shorts in on a couple of the caps. And again, I doubt it's low impedance. What about these ones down here? Yeah, we still got a short down here as well. Just checking around the first max IC area. Do we still have shorts on the pads? Where we remove the capacitors? Short there, short there, short there, short there, short there, short there. So removing the RAM, which is here by the way, hasn't got rid of these shorts. Let's remove the CPU. And that is what the underneath of a CPU looks like, which is why a lot of people don't bother reballing them, except for the coder, because we all know that he's a madman. If I had a stencil, I might have given it a go, you know, and just put a load of solder paste on and tried it, but I don't have a stencil, unfortunately. Let's see if the short is gone. Testing on these pads first. No short. Short to ground. Good. Good. Okay, so the short has gone bang, and the short has gone, thus proving that the CPU is the issue. Let's check our good friend M92. Okay, here we go. Short's gone, you see? There we go. So ground this side, short's gone. We have no pinging sound No beep sound, sorry, on where we did before. That confirms that this little CPU, or should I say big CPU from Nvidia, is foobar. The good news is that I can use all of the components that I took off in another Nintendo Switch Lite. Also, we know those two shorted capacitors around the M92T36 chip. If they are both shorted, the chances are that it is the CPU. I've learned something today. Leave a comment down below whether you thought the repair shop did a good enough job on that USB-C charging port. Sorry if I wasn't able to fix it. If you want to see me having a crack at fixing some more Nintendo Switch Lites, I'll leave a video up here for you to go ahead and watch. Thanks for watching, and I'll see you in the next one. Peace.